and consistency are so-called soft skills, which will be a key differentiator. The competition will be based on the talent, and there will be a premium on right attitude and learnability, along with the right technical skill. The need of industry are changed. We are looking for engineers who can see what others do not see and seize the opportunity to disrupt the status quo before you get disrupted by competition. On this brilliant occasion, I want to narrate the saying of a great person that has changed my mindset, my work, or my way to look at the life. Those words are, I want you to remember that performance leads to recognition, recognition leads to respect, respect leads to power. Therefore, my friends, there is only one way to make India a powerful nation, that is through performance. These are words by great Narayan Murthy of Infosys. So better performance comes from benchmarking with people, organizations, and nations that are better than us. Please remember three things. Do what you love, do it with faith, and while you are doing these things, do them as crazily as you can. It is very, very important that you trust yourself. You trust yourself because you are really good. Also remember that a happy mind achieves bigger things than otherwise. Therefore, have fun, be happy, and make people around you happy while you work or study. I am following this in my daily routine, and if you follow this, I'm sure that every one of you will be successful. Invited guests, ISF coordinators, distinguished participants, faculty members, ladies and gentlemen, with these few remarks, it is now my pleasure to declare the Oscillation 2022 is officially open. On this today's occasion, I extend my heartiest congratulations to the organizers and ISF team of VCET. May this institute grow from strength to strength and let the nation benefit from the commitment and skills of the students that pass out from this college. I once again thank the organizers, Dr. Gupta and Professor Saista, for giving me this wonderful opportunity of sharing my views. Thank you all for your kind attention. Jai Hind.
Thank you so much, sir. Oscillation is an annual technical event which was started way back, and various IETE SF Center has been actively participating in it. Proceeding with the event, let's talk about the game-changing technology of today, artificial intelligence and machine learning. These are transforming the world around us rapidly. Artificial intelligence and its the subset machine learning are the fuel that drive the digitalization around us today. We would love to hear more about this dynamic field by the honorable guest speaker for today, Mr. Shailendra Kadre. He is an experienced IT professional with demonstrated history of working in supply chain and marketing analytics. Skilled in machine learning and Python, he also possesses strong solutions, architect, and project management skills, along with an engineer's degree from IIT Delhi. He believes in never to stop learning and is currently pursuing a master's course at IIT Bangalore in artificial intelligence and machine learning. He also has a professional experience of 20 plus years in IT industry in digital transformation, machine learning, pre-sales, delivery, and multiple technical roles. His professional certifications are Project Management Professional PMP PMI USA 2009, Lead Auditor Information Security STQC Hyderabad 2009, MTech Design Engineering IIT Delhi 1994, Postgraduate Diploma ML and AI IIT Bangalore 2020-2021. Apart from all this, he has also helped HP to generate a revenue of USD 100 million plus in the last 5 years as an analytics and pre-sales manager. Program managers of 90 plus member ADMS team generating an annual income of USD 20 million. years for 4 years, and bid manager of successful USD 250 million deal applied material Santa Clara, a non-stop achiever. He is also the author of 3 international books in IT domain. Going Corporate, a Geek's Guide, A-Press USA 2011, 360 pages. Theme, Management for Geeks. Practical Business Analytics with SAS, A-Press USA 2015, 560 pages. Theme, Analytic for Beginners with SAS. Machine Learning with Python, McGraw-Hill USA, July 2020. Theme, Advanced Analytics using Python, which is in progress. Outside book, he is also a regular publisher of wide-ranging articles on LinkedIn and various other social media. We consider it as a great honor to welcome you, sir, for today's event. So as the wait is over, let's begin with the event. The topic for today's technical lecture is Introduction to Machine Learning and its Industry Application. Now I would like to call upon Sir, our guest speaker, Mr. Shailendra Kadre, to lead the event. It's over to you, sir.
Yeah, so thank you, Samruddhi, first of all, for such a nice introduction. In fact, I myself never thought that I have done so much. So thanks for reminding all of that to me. And I think that Dr. Parag, Dr. Harish, and Dr. Vikas has already told all the right words, so I need not get into those kind of things. So without wasting any more time, I would get into machine learning. And before I start my presentation, I would like to thank the management and dignitaries from IETE, principal and all the management members of VCET, Dr. Vikas Gupta, Professor Shaista, and all the young student friends who are present here for making it to this meeting and making me a chance to speak in this meeting. So with this, I will start my presentation. So I'm sharing my screen. Is it visible? Screen is visible?
Yes, sir.
Yeah. So all the right words have been said, I think. So I think I need not repeat because I'm not such a great speaker in these kind of management words and general things. So I better concentrate on technical things which I'm good at. So thank you everyone for making it to the meeting today. So I'm Shailendra Kadre, as you already got my introduction, and I would like to start today with a bit of like logistics, like how shall we proceed today. So I would like to quote the words of Mr. Chris Anderson. So nail the basics first and detail the details later. So that's how we'll proceed. So we'll have some slides on basics first, and after that we'll take a few details. And I would like 45 to 50 minutes. I will try to wind up my presentation. So this presentation is mainly focused towards students in mind. And so now this is my first slide. Okay. So what is machine learning? First question in your mind. What is machine learning? So I would say that all of this is machine learning. Like if you are a sports coach and if you are evaluating and predicting basketball players' passing tendencies, like basketball player is playing and you saw it's all historical videos. Based on that, you are trying to predict his next move. Okay. Then any website is talking to you, like say Flipkart or Amazon has appointed you as machine learning engineer. And for say holiday season of Christmas and New Year, you are predicting its traffic. So that is a regression problem. Another thing is a small restaurant. Let us come to a small restaurant. You are working as a consultant to this restaurant. And to help planning for this restaurant, you are projecting its future income. Okay. So what will help? Like if you are projecting website traffic for Amazon, what Amazon can do? Amazon can arrange adequate staff. Amazon can arrange adequate backend hardware, and they can prepare well for the traffic if they know the numbers. if you project the future earnings of a restaurant, so approximately it will give the idea to any restaurant owner that what kind of traffic he can expect, and accordingly he can manage the staff and infrastructure. So this is how you can help with machine learning. You can help different businesses. So these are all the examples of machine learning. So let us start with a few related terms. So machine learning, data science, business analytics, I would say these are all very closely related terms. Data science, business analytics, and machine learning, very closely related terms. And artificial intelligence is the umbrella term, which includes everything kind of like data science or business analytics. So on the right hand side, you see the figure where I have given the hierarchy. So top umbrella term is artificial intelligence. Below this we learn machine learning. In machine learning, we have neural networks, and in neural networks, we have deep learning. Apart from these related terms, we have few terms like data analysis and business intelligence. So I think these are related terms, but that doesn't exactly mean machine learning. They are related terms, but before machine learning, they used to exist actually. Business intelligence was existing in 1990s also, while machine learning, I would say, has come after 2010. Okay, so what is business intelligence? It is nothing but you have some data, and then you prepare nice report, nice dashboards. Based on some calculation, you present nice dashboards. It is nothing more than that actually. Nice reports and nice dashboard. That is what is business intelligence. But what is business analytics and machine learning? It is one step ahead of business intelligence. What step ahead? So you do predictions. You do the patterns in the data you find out. Then you based on your data, you suggest some actionable business item to your business owners. So it is one step advanced than data analysis and business intelligence. So I think you have some idea now. Next, we go to the definitions. So in simple words, machine learning is all about understanding the data and using it to make smarter decisions based on relevant information extracted. So I think already we have seen that. We are seeing the past historical data of past 2-3 years data of Amazon. And for this holiday season, we are helping them to predict the traffic on their website. Okay. So this is nothing but we are making, and based on that data, based on that numbers which they have for future prediction which they have, based on that they can make smarter business decision to say they can arrange more staff, they can arrange more concerned with computer programs that automatically improve their performance through experience. So there is some difference between the traditional programming which you are doing here. Machine learning is a program which learns through experience. Like you provide it, your historical data, whatever you provide, is nothing but your experience. And based on that experience, machine machine learning is extensive use of data. Machine learning is the extensive use of data. Then machine learning is uses extensively statistical and quantitative analysis. Machine learning uses explanatory and predictive models. And all this, why we do all of it? All of it we to drive better management decisions and actions. So based on data, we use some statistical tools on the data. We do some predictions. And based on that predictive analytics or whatever predictions or patterns we find in the data, based on that predictions or patterns, management is able to take smarter decision. Smarter decision means what? Smarter decision means to save the cost or to maximize the profit. Okay, just two examples. Generally, management is interested to cut the cost, maximize the profit. Okay, many more objectives can be achieved with the help of such decisions. Then we go for ingredients of machine learning. The most important ingredient is quality data. Data is the most important ingredient. After that, I will term second one as business or domain knowledge. Domain knowledge means, suppose you are working for a telecom company. So you should understand the problem which you are trying to solve. You should understand the telecom domain. If you are working for, if you are having working with the data finance company, so you should understand the business which that finance company is in. And once you have these two things, data and business knowledge, then you can apply some statistical or quantitative techniques or algorithm on that data to drive some actionable items. You can give some actionable items or some predictive analytics to the management based on these three things. But out of these three things, the most important is quality data. Quality data is the most important ingredient. Next is algorithms and business knowledge come next to it. But the most important ingredient is quality data. If your data is junk, you will get junk out. So remember this, more than algorithms and more than techniques or tools or software, data is more important. Okay. So this is the most important ingredient. Then next question to you, why should I study machine learning? So I would say that this is the data age and data is termed as new oil. So recently there was some article I read on LinkedIn in which we have done more, our software companies have done more exports than more exports than oil of Saudi Arabia. So I think Saudi Arabia did $124 billion. And our software companies did export of $138 billion. So remarkable actually. And of that, I will term that of that $138 billion, at least 25-30% was related to machine learning and artificial intelligence. Because for Infosys, 1/4 of revenue is coming from business learning, business analytics and artificial intelligence. Okay. So it is catching up very fast. And going forward, there will not be any software application which doesn't use data. All the software applications will be using data. All the software applications will be using artificial intelligence. All the software applications will be using machine learning. We are going towards that. Right now we are at 25%. So say next 5 years or next 7 years, we will be at 100%. Now, next is that business analytics or machine learning offers you a foolproof career. Because artificial intelligence is not something which is going to die very soon. Next 20 years, next 30 years, next 50 years. It is going to advance, advances will happen from one step to the other. You have to daily learn new things. Every year you need to learn new technology. But the underlying knowledge, the underlying business knowledge and the artificial intelligence umbrella will remain the same. And most important thing which you guys are interested as students is that it is offering great pay packages. I'll give you the kind of pay packages which students are getting. So I'm teaching in a management college. So freshers are getting salaries, minimum salaries as 9.5 lakhs per annum. And some students have got salaries up to 17 lakhs per annum. And it is not a grade, it is not a IIM or A grade college, okay? It is of course a good college in Bangalore, but it is not from IIM or any great college I am talking about. I know one lady, very young lady, with only 7 years of experience in my university. So that lady with only 7.5 years of experience is hired by Pepsi Cola in machine learning and data science. She is offering a salary, she is offered a salary of 27 lakhs per annum. So these are the kind of salaries which people are expert. You should be expert at, you should be good at your skills. Okay. You should be good at what you are doing. So these kind of salaries are people are getting, and you need for as an engineer, suppose you are a mechanical engineer or electronics engineer or a computer science graduate, what skills you need to enter into machine learning, artificial intelligence? First, many problems of data science are very simple, kind of. You have only 10,000 rows in your data set or table, 10,000 rows or say 1 lakh rows. So you can very easily manage it with the help of Excel sheet. Simple. Is the most basic thing we should you should be expert at as a machine learning engineer. Then next skill is SQL. Why SQL? Because nobody will give you data in an integrated fashion. Okay, nobody will say that this is the Excel sheet, this is the data, and I'm giving you the data ready-made, do analysis on this. Nobody will do that. How data will come to you? They will tell that these are 5 databases, different tables, and these are the conditions. You extract data from here based on these conditions. So how you extract data from database or tables? Everyone knows you need SQL for that, right? So SQL skill is the another skill. And once you have the data, another skill, as I said, is presentation skill, like exploratory data analysis, what we call it. Before doing the predictive analytics, you need to do some presentation, nice graphs, nice exploratory data analysis you need to do. So you should be adapted either Tableau or Power BI, one of these tools. Tableau is more common, but if you are not getting hold of Tableau, you can go for Microsoft Power BI. Once you have these expertise, I think I will suggest you to go for Python or R programming skills. So why Python or R programming skills are needed? You have extracted the data. You have presented the data with the help of Tableau and Power BI. Next step is nothing but predictive analytics. Or you have to classify in say fraudulent credit card transaction from good credit card transaction. You have to classify that. So for that you need some kind of programming. Okay, some kind of programming is needed. So either Python or R is programming is needed. So in that Python is more common. And then, as I said, all the machine learning engineers should be adapted to data visualization. Because sometimes what happens, simply if you plot the right charts, right graphs, and right dashboards, many data patterns are visible out of that. By simple chart, drawing a simple bar chart, drawing a simple line chart, or drawing a simple pie chart, many data patterns can be visible. So many data patterns are visible. You need not go into predictive analytics. So you should be adapted data visualization. These are the minimum tools which you are expected to master as machine learning or AI engineer. So many people ignore SQL and Excel, but I would suggest these are the top skills. Next. Now I will go into a bit of details like how ML works. So these are very basic things I covered for you. Then next we go how machine learning works. I will take a very simple example. Left hand side you see a dog sitting, a small baby sitting with a big dog. So what is it? So baby is very small. So say maybe 1.5 year or 1 year baby it is seen. And it is a home dog for, it is the pet dog for them. So it lives with them. It lives with this pet dog lives with their family. So what is the effect of this dog on this baby? So effect is this, that this baby recognizes how dogs look like 2 eyes, big ear, 4 legs, and friendly person, like very friendly animal. So he recognizes dog, right? So it is nothing but what is this? So it is training of baby. It is training of baby to recognize the dog. So in machine learning terms, what is it? It is training of machine learning algorithm with historical data. So what is machine learning algorithm here? So baby is equated to machine learning algorithm, and historical data say is nothing but say your dog. So with house pet dog, baby has learned how to recognize a dog. Few years later, like a few months later, the family brings a very small dogs for the baby, especially for the baby. Right hand side figure you see very small dog. Baby has never seen a small dog before, but baby still recognizes that it is a dog. How baby recognizes? Because previously baby was trained on how to recognize a big dog. A big dog how to recognize. Based on that, baby recognizes small dog also. So this is nothing but machine learning algorithm generating results on previously unseen data. So machine learning algorithm remains the baby, and previously unseen data. Unseen data means what? That the baby had never seen this dog before, small dog before. So it is unseen data. So it is nothing but baby is doing a prediction on unseen data. Baby never see this small dog before, and still baby is doing a prediction that it is a dog. So it is, in simple terms, it is how business analytics or machine learning works. We first train the machine learning algorithm with the help of historical data. Once the training of machine learning algorithm is over, then we apply it on the unseen data. And what we get out of that? By applying machine learning trained machine algorithm, we get, if we apply it on unseen data, we get predictions. Predictive. Traditional programming. So all of you, I think you guys might have done some Python programming or C programming by this time. Even mechanical engineering guys learn C programming these days. So in our days, we used to learn Fortran. So these days you are learning C and all. So what do? You have some data with you. You apply some logic on that. Logic is nothing but rules. So your input to the program is what? Your input is data and logic. With the help of data and logic, you do some programming with the help of C, Fortran, Java, Python, or whatever language it is. And the output is what? Output is processed data. Processed data is nothing but answers. But you see machine learning. How is it different? Inputs to machine learning program is answers and data. Answer is what? Answer means, I would say, you have to first tell it this is dog. And so you have to feed it historical data. So historical data means you have to say it is a dog. So that we feed answers. The answers are called labels. And you feed the relevant data. You do some training of machine learning program, and output is the rules. Output is the rule means based on that based on answers and data which you provide, your machine learning program gets trained. So here your machine learning program got trained to recognize a dog. So this baby learned some rules to recognize a dog. So output is the rules. So the basic difference is there between traditional programming and machine learning programming. Okay, so this difference you should know. This is a basic difference. Then we now get into some examples from everyday life. So everyday life, I think everyone uses Amazon these days or Flipkart these days, or every one of you goes to supermarket, right? So every one of you go to supermarket, and left hand side is the table which I have shown, transaction ID from 1 to 15. So they are nothing but raw transactions, like 15 customers have come to the shop and they have purchased different items in their shopping cart. There are different things. The first customer is having cookies, egg, milk, and sandwich. Second customer has purchased bottled water, burger, chicken, egg, pizza, and salad. Similarly, 14th customer has purchased cookies, egg, milk, and sandwich. 15th customer has purchased bottled water, burger, chicken, egg, pie, pizza, and salad. So these are nothing but random shopping carts of 15 customers. So what we do, you feed this is the raw data. This raw data you feed into a machine learning program. So machine learning program learns that generally with what item with which items people purchase together. Machine learning program learns which items generally people purchase together. So now you see your example, like you are going to Amazon or Flipkart or Mantra or any other fashion site. You are purchasing trousers. Okay. So you purchasing trousers, and with that, once before you are going to check out for the billing, recommendations will come below. People who purchased trousers also purchase this item. So it will show you say t-shirts or shoes or those kind of things. So what is it? So it is trying to make you sell. It is trying the machine learning program. It is a recommendation system. It is trying to. It is making you buy more. Why? You purchase only trousers. You wanted only trousers, but 10-15 recommendation below will come. So there is likely that, yeah, boss, I need. It is a reminder to you. I have trousers. So with these trousers, I need brown shoes also. Or with these trousers, if it is a ladies trouser or something, they may remember I need this kind of top. Okay, so it is likely that you will click one of them and add the top or shoes also in your shopping cart. So what is the advantage to retail store? They have increased their sale, right? So how they have learned that with trouser people buy either top or shoes? How they have learned it? It is a simple example I am giving. They have a machine learning program running behind, which has learned based on this raw data of this kind. This raw data of 1 to 15 transaction was fed into the machine learning program. And like this, millions of transactions were fed to the machine learning program. And based on that, it gives you recommendations. So Amazon, you buy a book. One subject book you buy, Amazon will give you 5 more recommendations. People who bought this book also bought this book together. So 4 or 5 more books they will give you a recommendation. So how they learn it? So based on this raw transaction, they have feed to the machine learning program. And when machine recommender system runs, when you do the purchasing, that time it gives you some kind of suggestions. Next example is your McDonald's. Like McDonald, like people who buy burger or French fries, always order meal like you burger and French fries. If you order, you will always order Coke or Pepsi drink. So what they do? They price burger, fries, and Coke together and call it a Happy Meal. So price of these different together item, different item add together will be $20. And they will price Happy Meal at $17. You say, yeah, boss, I want all these things. 3 things I want, and price is also $3 less. So happily you will buy. So this kind of programs are called market basket analysis. It is another kind of machine learning program. So one I told you recommender system, one I told you market basket analysis. Then let us get into some bit of technicalities. So I want to differentiate between supervised and unsupervised machine learning programs. So what is a supervised machine learning program and what is the unsupervised machine learning program? So when you tell a machine learning program that the answer you tell, label you tell, answer you tell is the before itself. Let us treat this small baby as machine learning program. And you are telling answer the previous means beforehand you are telling the answer to baby that this is the dog, and after that it is recognizing the dog. These kind of programs are called where you tell labels or answers. If you tell in advance, and then you train the machine learning model. These kind of machine learning models are called supervised machine. So what is happening here? Here you have input data. Here you input data, left hand side. One is a dog image, one is a cat image, one is a sign image, like this sign image. You are feeding it to a neural network program. Neural network program is nothing but an advanced machine learning program. So while feeding the program, you are first, when you are training the program, you are telling that this is the image of a dog. You are categorically telling this is the image of a cat. This is the image of a victory sign. Like that, categorically you are telling that machine learning program while training category, and like that millions of record you feed while training. Once machine learning program trains, then any cat photo you show to that, any cat photo you feed into that machine learning program, it will classify it as a cat. Or any dog, any five six different categories of images you feed to that machine learning program, it will correctly classify that this is dog, this is cat, this is a victory sign. So when we supply labels or answers beforehand, that is called nothing. That is called supervised learning. So what are the examples of supervised learning? Like supervised learning is used in housing price prediction. You are a real estate agent and you want to make a machine learning program to predict the price of houses based on attributes of the houses. What are the attributes of houses? How many bedrooms? How much is the square feet area? What is the location? Or how many stories it has? These are the attributes of the house. So once you feed the attributes of the house, your program should automatically tell you the price of the house. Okay. So how you train this machine learning program? Previously, whatever old data you have, so all the housing data which you have, historic data, you know the price also and you know the attributes also. You know the price as well as the attribute. You feed into machine learning program, train it. Once it is getting training, then you feed only the attributes. You don't feed the price because you want to know the price. Don't feed the price. You want to know the price. So what happens? Once your machine learning program is trained, you just feed the attributes that will tell you the price. Because similar prices, similar attributes and prices you had feed in the past and you had trained the machine learning program. So this kind of learning is called supervised learning. So supervised learning is mainly classified into two categories. One is classification and one is regression. So classification is very simple. Classification is very simple means like you are going to you are applying for a loan in a bank. You are applying loan in a bank. So you give a lot of data to bank, right? You give a lot of data to bank. So your demographic means your personal details, then your income, then your family history, and a lot of other data you give to the bank. What bank does, there is a 3-page application, usually 3 to 4-page application, a lot of data bank collects before giving you a loan. So all that data is fed into a machine learning program. So machine learning program will decide, will tell the bank manager whether to give the loan yes or no. So if the machine learning program tells that approve the loan with 90% probability, means he is a credit-worthy customer, approve the loan because his credit-worthiness is 0.9. Like that, machine learning program output will be his credit-worthiness is 0.9, you can give him the loan. Or his credit-worthiness is only 0.4, you cannot give him the loan. So like yes or no decision only. Classification, only yes, either give the loan or don't give the loan. So these kind of problems are called classification. Regression is, I explained you many times, like I told you to project the of a restaurant. So future income of a restaurant cannot be yes or no. It is a number, continuous number. So either it can be future income, say next 3 months, the projection is that first month $30,000, second month $20,000, and fourth month, because it is a festival season, again $50,000. So that is the weekly income that you have projected, or the monthly income you have projected. So regression is nothing but projection into continuous numbers, like housing example which I gave. Housing example which I gave you, predicting the price of a house based on the attributes of the house. So that is nothing but a regression problem. So they are generally divided into two type of supervised learning is divided into either classification category or regression category. Then there is one more category of machine learning programs. I will not take into too much technicalities of machine learning. I am keeping it very simple. After this, we will go into examples. Okay. So unsupervised learning is what? We don't supply the labels. We don't supply the labels. We don't give the answer to, in the historical data, we don't give answers. In supervised learning, we give answer and labels also. But in unsupervised learning, we don't give any labels. And still we want program to categorize the data. What is the example? Like you are working for a telecom company. So it has a huge database of customer. So some customer are giving billing below $200 per month. So they are in low billing category. Some customers are giving monthly billing between $200 to $500 per month. I'm just giving example. Okay, these don't treat as a real number. So some customers are giving example between $200 and $500. So they are medium billing customer category. And some customers are giving above $500 per month. So they are in high category, high kind of high. So these are simple example I have given. So this kind of data, once you feed, computer program will automatically segment into low category, medium category, and high category. But this is very simple example. Once you feed, when you have the data of customers, telecom company customer has data, it doesn't classify based on only one attribute like how much is the monthly billing. So based on only one category, you can also classify. Human can also classify. In Excel sheet, you put below 200 all low, between 200 to 500 all medium, and above 500 all high billing customers. That only get, but we classify based on many attributes. Attributes means there will be, say, based on 20 customer attributes, we have to classify whether customer is a low class category, middle class category, or high class category. Based on 20 attributes, you have to classify this. You cannot do manually. So this kind of data is fed into computer. But we don't tell computer which one is low, which one is high, and which one is middle. Computer automatically classifies which is low, which is high, which is middle. So one simple example I am giving you. I am mixing here three kind of vegetables: red, and then violet, and some kind of potato colors. Mixed data I am giving, and I'm not telling computer program which is potato or which are other two vegetables. I don't suppose they are vegetable 1, vegetable 2, vegetable 3. I don't tell computer which is vegetable 1, which is vegetable 2, which is vegetable 3. I just feed this data, these images into computer, and I want computer to separate. Which one is all? I want computer to separate into 3 categories. So see, so that kind of problem is called unsupervised learning. So this kind of data, images I feed, sample images I feed. So computer will give me right kind based on some attributes. Computer will automatically classify which is vegetable 1, which is vegetable 2, which is vegetable 3. Maybe based on color, maybe based on weight, maybe based on shape, or maybe a combination of them. So this is unsupervised learning. So unsupervised learning is I gave you example of a telecom company, customer segmentation. It is used in customer segmentation by marketing companies, telecom companies. So based on 20-30 attributes, they want to classify customer for email marketing, targeted email marketing. They want to divide customer into 3 categories: low, medium, and high. And based on 20 attributes, they want to do this classification. Okay. So they feed this kind of data into a unsupervised machine learning program. So K-means clustering is one such machine learning algorithm in which they feed it. Automatically, the computer, based on some calculations and some attributes, computer classifies. This is the low category, this is the medium category, this is the high category. So accordingly, email marketing is done. For low category, different emails are sent, different product emails. Medium category, different emails, different product emails, and for high net worth customer, different kind of emails are sent. So this is nothing but unsupervised learning, where we don't tell the label or answer beforehand to the where we don't tell labels or answers beforehand to the computer while at the time of training. But in case of supervised learning, when we supply data, we tell it computer that when we train, we tell it is a dog, it is a cat, it is a victory sign. We tell the computer. But here we are still training the machine learning program, but we don't tell which is vegetable 1, which is vegetable 2, which is vegetable 3. So based on some attributes, computer classifies. So these are two main categories of computer machine learning problems. And this is my last technical slide. So machine learning, you can see this. So there's different steps in machine learning program. Data acquisition, data cleaning is the very important step, which takes 70 to 80% of time of any machine learning project. Data cleaning it takes. Then model building takes around 10% of the time. Then model testing takes another 5%, and another 5% time is taken by model deployment. So there is a loop between model testing and model building. So if we find that model testing, a model which we have done, machine is not trained accurately, or accuracy is not good, then we again do one more modeling. So like that, we have loops. It is a project cycle of machine learning project. Now we get into some examples. So applications of AI, if you ask me, you are reading newspapers, English newspaper, magazines. So applications of AI are everywhere. Healthcare, education, autonomous vehicles, everyone knows, like California is already started running autonomous vehicles. So it is nothing what, it is what the application of advanced deep learning. Okay, then travel industry, to predict the price patterns of aircraft. You want to travel to US, and price pattern you want for next 3 months. How the prices vary from Mumbai to, say, New York. How the prices are going to vary for next 3. So this kind of prediction you want. So these kind of predictions. Then social media. Then business. Business is heavily using. Business is a very generic term. So all these things are using. So let us get bit of specific into bit specific. Let us go and get into finance. After that, I'll get into electronics also. So let us get a bit specific. Finance. So these are the applications. I don't want to confuse you with jargon. I'll tell you with just one example. Credit cards you are using. Everyone, your mother, father at least are using credit cards. So you go to a jewelry shop. Your mother went to a jewelry shop, and he has done a costly jewelry purchase, gold purchase of 2,80,000 rupees. 2,80,000 rupees. So bank does what? Based on your credit card history, transaction history, your customer data, like details of who customer of the credit card, which is your mother in this case, and your transaction history, the place of the history, and what kind of purchase you are doing. Suppose you are doing this kind of heavy transaction, 2,80,000 rupees transaction first time, then it is something alarming to the bank. Alarming to bank that this lady, I have issued credit card 5 years back, but this kind of heavy transaction of 2,80,000 rupees, this lady has never done. Okay, or so immediately the bank computer will raise an alert to the backend team and say that this kind of transaction is being processed. Shall we approve, yes or no? Sometimes what happens? Immediately bank will call your mother's phone number. Bank will call your mother's phone number, and they will verify whether it is you or some fraud person is doing that assignment. They will call your mother and they will verify based on details like give your date of birth, what is your last transaction, where do you live, what is your maiden name, all those details they will ask, and they will want to verify whether yes, it is your mother who is doing this transaction. And they will ask whether should I approve this transaction. If your mother says yes, they will approve. But now what happens? I am doing some shopping today. Shailendra Kadre has gone to, say, Bangalore, Mahatma Gandhi Road. MG Road is the famous shopping site in Bangalore. So I go there today evening, and I do some shopping. Say some food items, some fashion items, little small items I purchase on MG Road and come back to my house in JP Nagar. Now, next morning, 6 o'clock. My credit card is being used in US. My credit card is being used in United States. So bank will get an alert. Before they approve, they will get an alert that if some automatically machine learning program will alert this gentleman was doing evening 7 p.m. He was in India, and morning 6 a.m. this transaction is happening in US. How in within say 11 hours he can fly to US? So what they will do? They will block my credit card. They will block my credit card. They will not allow my transaction to go through and immediately alert me. Yes, Mr. Shailendra, your transaction is copied, or your credit card is being copied by somebody, and it is being wrongly used in USA. So we have blocked your credit card. Please we'll issue a new credit card for you. So what bank has done? So bank has done a fraudulent transaction from being processed. Like fraudulent transaction when it goes through a credit card, it is bank's responsibility. It is a bank's responsibility. If credit card is fraud, it is not customer's responsibility. It is bank's responsibility, because credit card processing is done by bank. So bank has, if in a day, a bank, if suppose stops 1,000 such transactions. 1,000 such transactions. So maybe $1 million or $1 million they have saved in a day by identifying fraudulent fraud transaction in advance itself. In real time, they are doing the analysis whether transaction is a fraud or it is real, based on some attributes of your transaction, based on your attributes of your customer attributes, based on the place you are doing, based on the value of your transaction. So based on so many attributes, in the real time itself, they are determining whether your transaction is fraud or good or bad. So our fraud transaction, they are stopping there itself. They will not approve. Your credit card will not work in US and they will block it. So this is one of the application how finance companies are using it. Bank is a finance company, right? They are using it. Now algorithmic trading is another example everybody knows. Nowadays, people nowadays, robots are doing stock trading for you. Robots or computer program or computer algorithms are doing stock trading for you. So it is proved that they are doing it better than humans. Better than humans, they are doing algorithmic trading. So these are the two simple examples which I want to give you for how finance companies are using it. Then healthcare. Healthcare, I want to give you one example. You are a doctor, or your brother is a doctor. He is sitting in a big hospital. He is, say, cancer specialist. He is sitting in a big hospital. In a big hospital, for daily 1,000 customers, suppose, just giving a number, example number, 1,000 customers come to for cancer diagnosis. So all customers have to go through X-ray, chest X-ray. Okay, chest example I'm giving, 1,000 customers have to go through chest X-ray. So they result in 1,000 X-ray images. And how much do you think will be having real cancer out of these 1,000? 20, 30, not more than that. Out of 1,000 which X-rays which that your brother as a doctor is going to examine, only 20 or 30 are going to have X-ray cancer. The rest 970 will be okay. They will not have any disease, only some small cough, cold or something, and or gastric problem or some other problem will be there, but cancer will not be there. So what is happening now? Your brother, just for detecting 20-30 positive cases, 20-30, he is wasting his time to examine 1,000 chest X-ray images, which is a waste of time for him. Instead, you do what? You deploy a machine learning program. Machine learning program is nothing but image processing program or computer vision or image processing program you deploy. And all the 1000 images you feed, instead of showing to your brother as a doctor, there's 1000 images are getting feed into that particular machine learning program. What machine learning program is trained in identifying chest X-rays which are having cancer. Machine learning program is trained to identify cancer in X-rays. That is how it is trained. So what that computer program will do? Computer program will, out of that 1000, say 50, it will classify computer program that 50, with 80% probability I am telling that this 50 may have cancer. Out of that 1000, only 50 he will classify that with 80% probability I am telling that they may have cancer. Rest 970 it will say they are healthy. With say 90% probability, it will tell that 970 are healthy. So what your brother will do? Your brother will not look at those 970 which computer program has told us healthy. Your brother, instead of now 1000 X-ray images, he will see only those 50 images which are classified as cancerous by that computer program. And out of those 50 programs, with manual intervention and with his expertise as a doctor, he will reject 20 and say, boss, out of these 50, 30 are really having cancer. These 20 are not having cancer. Okay, so what you have done? You have saved it, or you have saved a valuable time of a doctor. So instead of looking at X-rays and wasting his full day in looking at X-rays, he can do some operations, or he can do some more productive job, right? Or instead of 2 doctors to look at X-rays, you can put only 1 doctor, because now computer program is doing most of the job. Manual intervention is still required, but manual intervention is required above what classification has been done by machine learning program. So this is a example application I have given in healthcare. Then now I am moving to electronics, because Dr. Vikas Gupta categorically told me that you have to give some examples specifically to electronics and communication engineering. So let us get into that couple of things. So electronics and telecommunication engineering, I will say AI is everywhere. It has get into research development, how machine vision, voice recognition, audio processing, and also what machine learning programs do. So with machine learning programs, organization develop a better understanding of user context. In what context user is talking to us, user behavior, and user preference and needs. So this is a very simple example of customer analytics, which these telecom companies or consumer electronics companies can use to identify customer behavior. They can identify customer preferences. They can predict their needs. In manufacturing, what AI can do? AI can reshape product development cycle. Like suppose it takes 6 months to develop a product. With the help of AI and automated tools, it may be possible that a new product can be developed only 2 months. Then product design process. Product design process nowadays is automated. So if you are doing it manually, maybe it may take 1 year, but with the help of automated and machine learning, machine learning AI, the product design processes can be done only in say 1 month. So you are reducing by 10 times. Then definitely with the help of automatic robots, so use of robots and artificial intelligence, you can reduce defects. You can deliver product faster to the market. You can reduce the number of defects which are otherwise done in manual processes. With the help, if you deploy AI, number of defects will be reduced and your time to market will improve. Okay, then another area is security, where AI is helping a lot. So like a lot of devices, you have connected devices, what you call Internet of Things. Lot of devices are connected these days. So they now currently only computers are connected to internet, but what they want to do already done. Okay, fridges are coming. Fridge you can connect through the internet now. You can control your fridge from your office internet. So it is already connected. One new fridge we have purchased, it is already having an internet connection. So if fridge can be connected from the office, it is open to hackers also. So security is very important, all these kind of devices. So in adding extra security, internet and like finding the threats, security threats, AI is classifying the threats, AI helping a lot in that areas. Now let us get into more specific. Let us get into chip design and testing. So if you are taught in final year or say if you are in final year or now we are in last few slides. So if you are in final year or something, you might have learned at least the steps of chip manufacturing, computer chip manufacturing, which Intel is following or any other chip manufacturer is following. So these are the steps. Actually, I am a mechanical engineer, so I will not be able to get you through all these steps. But the today aim is not to go through these steps. You see, there are all these steps. Now what I'm doing, I'm taking one step out of it, which is chip design and testing. When chip is made, I'm taking one step out of it. Chip design and testing is an important step. So I'm taking chip design and testing, and I want to demonstrate you what kind of machine learning algorithms are used. So chip design and testing nowadays steps I have listed here. So convolution neural network, CNN they are using. Graphical convolution neural network, GCN they are using. Multi-layer perceptrons they are using. Support vector they are using. And many more these kind of algorithms which I have listed here in the table above. All machine learning programs, this kind of machine learning algorithms are getting used in a single step. I am listing single step. There are more than 20 machine learning algorithms which nowadays companies are using, which is nothing but chip design and validation. Right now, we are not going into how they are getting used, but just I want to make a point. Just in a single step of chip manufacturing, which is chip design and validation, more than 20 computer programs which I have listed. I got through them. I got them through a research paper. So I thought I should, in just one step of chip design, they are using more than 20 machine learning algorithms. If you list for, there was a big list for all these steps. They listed for all these steps. So more than say 120 machine learning program they had listed for full chip design cycle or full chip design manufacturing and marketing cycle. They listed more than 120 more than 120 machine learning algorithms which are getting used. Now let us get into telecom. So telecommunication engineering. So let us get into telecom now. So this is a beautiful slide which I got through one of the presentations of my friend. So I'll give only one example here. Like you are Jio is a telecom company, or say Airtel is a telecom company, right? So how they are using how they are using AI? I think that example I have already given to you. They are segmenting customer segmentation. They are doing based on a lot of customer attributes. They are using unsupervised learning to do customer segmentation. So this is very high level use of AI in used by telecom companies. But if you see, AI is as I have listed here in the application category. So they are using AI for network security. They are using AI for network optimization, customer analytics. I already told you, virtual assistant, self-diagnosis. So these are some areas which I just want to list you just to tell you how these companies are using, how wonderfully these companies are using AI to their advantage. They are using in network security, network optimization, customer analytics. Every step now they are using AI to reduce the cost, to maximize the profit, and to maximize the utilization of their network bandwidth. They are using AI. Without AI, these companies cannot run these days. Okay, so that's where giving one example in telecom. Now let us get into supply chain, electronic supply chain. So electronic supply chain, electronic component supply chain, how is it? It is important in consumer electronics. So consumer electronics is what? Your TV, fridge, or mobile phone, or say your tablets. All these things are your consumer electronics, right? Electronics which consumer like us, like you and me use daily life. So in that electronic component supply chain is very important. So see where they are using. I'll keep this slide open for a couple of minutes. So let us go into manufacturing first. Previously, humans used to do inspection. Now they are doing automated inspection using visual inspection, CNN programs. Predictive maintenance of their machines, which was previously breakdown. So now from breakdown maintenance, they have shifted to predictive maintenance. Like before machine fails, machine learning program tells that this particular machine is likely to fail between week 3 of our manufacturing. During the week 3 of manufacturing, this part is likely to fail. That machine learning program will predict. So what is then? Then what you will do? Your maintenance engineer will go inspect that whether this program that is really, that bearing or that particular part is really faulty. Even if it is going to fail in the 3rd week, today night itself I will replace it, because in 3rd week I don't have any disruption. Then statistical process control. Everyone has heard of statistical process control. Then you go for supply demand side. So like anybody who is familiar with a little bit of materials management or those kind of things, you have supply forecasting, demand forecasting. You have two sides, supply forecasting and demand forecasting. So if you do this thing accurately, your supply chain and all can be planned very accurately. Very accurately it can be planned. If you have very accurate demand forecasting and very accurate supply forecasting, you can very nicely and optimize, you can very nicely plan your supply chain, your factories, your machines, your logistics. You can very nicely plan. And you can optimize it to the maximum advantage. Nothing is waste. Your factory capacity is, say factory will be utilized more than 90% if you are doing this forecasting correctly. Then last step, if you take, even if you have manufactured, you have to supply, say all India, you have to supply your TV, TV manufacturer. So whatever you have manufactured in Mumbai, you have to supply all over India, right? Your factories in somewhere near to Mumbai, Nashik, or nearby place you have factory, and from there you have to supply to all India. So multiple trucks will go. It will go by train. Some may go by air. Some may go by say multiple trucks will go. So all this is called logistics, right? Logistics is not a simple thing. You might have, if you are in final year, mechanical engineering students, at least I know they learn operations research. So operations research, they learn how to optimize logistics. So with the help of your machine learning programs and your computer programs, you can optimize logistics. So what I mean to say is, just in supply chain, I have listed a few fields. Somebody's talking or somebody?
Sorry, sir. 1 second, sir. Will mute. 1 second.
Yeah. So I have listed few areas of supply chain. Everywhere it is being used. Machine learning is being used. So you take it like this. Now anywhere computer programming is being done, machine learning is invariable part of it. Anywhere you are using automated things or computer programs, machine learning is an invariable part of it. If not today, 2 years, 3 years or 5 years from the now, every machine learning program which will come out in every field will have machine learning component. Already a lot of thing is going on. Then with my last slide, I think, last 2 slides, I have, I want to just list, there's some abusing actually, some guys are abusing on the, so there are top 9 applications of machine learning program I want to list. So I just want you to read yourself. These are the top areas where machine learning is getting used. So this is how, and this is one slide where this is where you say that adoption. So retail means your Flipkarts and Walmart and Amazons of the industry. They are the first guys to use analytics. So they are around 30% of that industry has already adopted analytics. Second is banking and finance. So 20% of banking and finance industry has adopted. After that, you have telecom. Then after that, you have health. After that, you have healthcare, and 16% are other, which I have listed in the left-hand side. So still, if you see, retail is adopted. In retail also, adoption is only 38%. Retail also, which is on the top, adoption is at only 38%. So there is a lot of scope for ML adoption is every sector. So there is a lot of scope for new ML engineers, but you should be skilled at that. You should be skilled at that. I think I stop here, and a couple of questions, or if you want to take those kind of things, we can take up. Thank you, everyone. Thanks for your attention. So I think some people lost patience actually. So somebody was unfortunately abusing in the presentation itself. Anyway, it is a part of life, so we don't get moved by these things. So that is how it is. But I think you've got some overview of machine learning today. And if you have students have any questions about their career or the skills required or any other doubts regarding machine learning and things, I think we can take it up. So anyone has any questions, they can take it up. So I keep open on this particular slide where you see the top applications of machine learning. So yeah, so you want to ask in chat, you are free to ask in chat also. I'm looking at that. Somebody has put array. Okay, I don't mind that. What machine learning models have you worked with? I have worked with traditional machine learning, which is linear regression, logistic regression, then support vector machines, then random forest, then XGBoost, and then I have worked with deep learning programs like neural net, ANN, CNN, and RNN. These I have worked with. And then I have worked with some natural language processing model like BERT, so transformer models and BERTs. So I want to. There is next question is how does machine learning differ from deep learning? So I want to take you to the very first slide, which is I have showed the machine learning and deep learning difference I have showed. So see, deep learning also is a part of machine learning. But machine learning is a wider term, and deep learning you can say a subset of it. So more advanced techniques nowadays are called deep learning. Okay, so I think it is understood. So deep learning is what is currently going on. You should traditional machine learning is anyway. Traditional machine learning is something which many people know these days. So now from 2017-18 onwards, more research is going in the area of deep learning. And as machine learning engineers, you are expected to know deep learning these days. So deep learning is nothing but neural networks. Machine learning and AI, I will share one site. I'll share one site with you. I'll stop sharing. I'll share one site with you for machine learning and AI, which is nothing but my own channel in Hindi if you are comfortable. And nowadays I have started in English also. So my own channel, you can have a look if you wish. And there are a lot of other channels also available on machine learning. So I will share one channel. List of one channel, so you can subscribe to this channel, and you can subscribe to this, and so ML channel I am listing here. I want guys to unmute, and this channel has Hindi, English both, so it's my own channel, so it's your preference. Otherwise, you have other lot of other channels also available here. English, there is one Krish Nair. Search for Krish, Krishnaik, Krishnaik, you search. You will get a nice machine learning channel of this guy.
त्याला कीप त्याच्यावर लक्ष ठेव, तो आला तर त्याला बंद करून टाक.
Very informative lecture. Thank you. Thank you. Great explanation. Thank you. Thank you. How do you angle missing or computed data on the data set? You want to learn these specific things in this lecture? This was a very overview lecture. So there are a couple of options to handle missing data. So like if missing data is more than 50% or 55%, we reject that column. That is one thing. That is not useful to us. Then if missing data is at 10-20%, sometimes we suppose it is a numerical column. So very simplest thing is to replace all the missing values with mean. Or sometimes we replace missing values with 0. Or if it is a categorical column, then we replace categorical means string type of column. Then we replace with maybe mode. Mode is means most frequently occurring value. So like that we replace. Or sometimes if there are a lot of outliers in that, then in that case mean is not the right thing to do replace with. We use median to replace. So this is how we do it. And apart from that, also there are a lot of other techniques to handle missing data. Sometimes we take the help of label also, Y variable also to replace Y variable also we take the help to replace to compute the missing values. Sometimes we use some machine learning, simple machine learning algorithm itself to compute the missing values. So a lot of options are there. So depending upon the use case and the data set, you use it.
Blocking.
Then next question is, could you tell us something about TensorFlow? See, TensorFlow is a nice tool by Google. It is something you can. It utilizes mainly Python only, and it is used to code deep learning, CNN, ANN, deep learning or neural networks. If you want to code, you have to code with the help of the TensorFlow. It's an excellent tool. So there is a combination, TensorFlow and Keras. So with that combination only, you have to do the coding of deep learning neural networks. Okay. And any more question? Bas karo kitna?
Sir, I'm very sorry.
No problem, madam. We are used to it. Don't worry, madam.
Yes, sir. Sir, actually we are removing him, but now we have stopped the chat box.
No, madam. Such elements are everywhere. Don't mind. Let him be. Let him do whatever he wants.
Thank you so much, sir, for understanding, because we are removing him, but he's.
Ignore, madam. Ignore. We are used to it. Don't worry.
Okay.
Let him put 2-3 more comments.
Sir, can I ask one question?
Sure, madam.
Sir, actually, sir, image processing. So, sir,
Yeah.
for image processing, mainly we are going for deep learning algorithms.
Yeah, deep learning. Yeah.
So, sir, but sir, deep learning algorithms are more difficult. Means time consuming.
Yeah. They are time
And
consuming.
sir, image is a very large data. Means when we work on. So,
Yeah.
even though, so sir, can you tell me what is the
Madam,
benefit?
first of all, it is a wrong notion that we use only deep learning. You can use simple machine learning algorithm like support vector machine also for processing image.
Okay.
Simple. The support vector machine is a traditional machine learning algorithm which you can use. Okay.
Okay.
But generally, 95% of the cases we go for deep learning.
Yes, sir.
So first of all, if you are working with deep learning program, and if you are doing any serious application, then you better go for Google Colab Pro. You have to subscribe to Google Colab Pro.
Okay.
You don't do on your own machine, because if you run on your own machine, it may take 10 hours, 20 hours to run the same simple program also.
Yes, sir.
So go for some cloud subscription like AWS or Google Colab Pro. So I generally take a subscription of Google Colab Pro, which is very cheap, $11 or 870 rupees per month.
Okay.
And you can utilize it 24 hours, no problem.
Okay, so sir, the Google Colab which is available, the Pro is the paid.
Yeah, say $11 you have to pay per month.
Okay.
And there is no time limit, madam. 24 hours you can use it.
Okay, that's good. Okay, sir. Thank you so
So
much.
you better take that, and on that only you run your deep learning programs.
Okay, okay, sir. And
See, if you are working for machine learning, Java and C is not good. Only Python you have a lot of libraries available.
yes, sir.
So Python is very good language for machine learning related programs.
Okay.
If you are working on general software, then maybe in some cases C++ you want to use. If you want to use system programming or those kind of things, then you may go for C++. Or Java may be useful in some cases. But if you are working with machine learning program, then only out of these three, one gentleman has listed, Prakash, Python, Java, C++, only Python to be used if you want to use machine learning. What is the accuracy of face recognition? There is one question by Anthony. So the accuracy of everything is very simple. Out of 100 cases, how much I am recognizing correctly? How much I am recognizing correctly? Like suppose your college has installed face recognition system in the college. 100 students show their face and retina reading or whatever it is. And out of 100, if it is classified, 98 student, if it is classifying correctly by their name and giving right attendance for 98 students, then accuracy of that program is 98%. How many faces it is recognizing correctly, percentage of faces it is recognizing correctly is nothing but your accuracy of your face learning, face recognition program. Definition is same for anything. Accuracy definition is same for anything. Thank you, Karan.
Okay. So, sir, I think so. We have got, sir, even though we told students, so like they have some queries because now they got the at least basic understanding of ML. So I hope like when they study, they'll further understand the, they'll find more doubts.
Yeah, first of all, you guys have to do mastering Python. After that, only you attempt machine learning. Okay.
Yes, sir.
First, you do mastery of Python. 3-4 months, don't touch machine learning. Master Python only. Once you master Python, then go for traditional machine learning.
Yes.
Next question by Parag is, can you throw some light on result interpretation using data analysis? So it is something called exploratory data analytics, EDA. I will type it here. It is called EDA. You search for EDA. I have to show you some plots and all to show what is it. So you better Google for EDA. Exploratory data analysis. You Google for exploratory data analysis, EDA. Then you will get a lot of figures and a lot of article about it, which you can read one of them. I have to show you Google before. I cannot explain just like that.
Okay, sir. Okay, thank you, sir.
Yeah, no problem. Thank you, sir. Any other questions?
So, sir, even the students will, sir, I told students to give the questions if they have, like, I can mail you, sir, for some of the questions if they are having a doubt.
Yeah, I will be very open with you, Sohan. I have not heard of these two tools because I have not used it.
The better for machine learning,
I have not used it. So generally, there must be for some specific use. Generally, we use Python libraries and we use TensorFlow, Keras, or we use PyTorch. So these libraries I have not used in general purpose machine learning. I'm not sure. Maybe if you Google, you can find the answer.
So Raspberry Pi is used, basically it is using Python. So
Python,
probably,
yes, sir.
yeah, that is why.
Arduino.
No, I'm not aware, sir. I'm not aware. And you see this, I'm a 51-year-old young guy and I am still hands-on in Python. Okay, mind it. I'm still hands-on in Python. I code myself. Okay. So you have to remember that example. I still code myself. I don't need any assistant for coding or those kind of things.
That's good, sir. So
I think if no questions, I think we can end, I think.
okay, sir. Yes, sir. Yes, sir.
I think before you conclude, maybe I would like to say something. Shailendra sir, thank you very much for
Yes,
your.
sir. Yes, sir.
Yeah, thank you so much. Actually, I am humbled actually that I am very thankful to you, college management, Vikas Gupta sir, that I was invited to speak in such a prestigious conference. So I am humbled. I am really humbled, sir. Thank you so much.
We are looking forward for your guidance in strengthening in this area of machine learning, artificial intelligence. And
Sure, sir.
maybe
Anytime.
What we should do at the institute level, we'd like to have your guidance for that.
Sure, anytime, sir. My pleasure. Yeah, my pleasure, sir.
Yes, Shaista ma'am, you can continue.
Yes, sir. So, sir, first of all, I consider this occasion an honor and privilege to extend the vote of thanks. So, on behalf of college management and all the students, I would like to thank Mr. Shailendra sir for taking his precious time out. And sir, your webinar has taught us and our students a topic which is very demanding in market, and you taught us in very efficient, like very simple and very efficient way. So, thank you so much, sir. I would like to thank our management for being always our support. I would like to thank Mr. Parag Walinskar sir and the executive committee of IETE Mumbai Center for trusting us by giving the opportunity of inauguration of Oscillation 2022 and gracing this occasion with their presence and support from IETE Mumbai Center. I would like to thank our ISF in charges of various colleges for being present for the event and encouraging their students for attending the webinar. Today we have with us ISF in charges Smita Lonkar ma'am, Treasurer IIT Mumbai and ISF in charge of Jonsley College. So Dr. Sohana Bise ma'am, who is Secretary IIT Mumbai Center and ISF in charge of Vasantdada College. Miss Vinuta ma'am, ISF in charge of Shailendra College. Miss Poonam ma'am, ISF in charge of Don Bosco College. Miss Archana Belge ma'am, ISF in charge of Thakur College of Engineering. Miss Jocelyn Gracious, ISF in charge of Atharva College of Engineering. Mr. Chinmay Raut, ISF in charge of Universal College. Miss Purnima ma'am, ISF in charge of KC College. And we have Dr. Rinde sir also, who is the ex-chairman of IET Navi Mumbai Center. And sorry if I forget any of the ISF in charge who are present. So I thank all of you because without you, this event is not possible. I would like to extend our gratitude towards respected principal sir, HOD sir for their endless support, guidance and motivation. I like to thank my IETSF student committee for their effort for making this event successful. And I would like to thank all the participants for attending the seminar and being a wonderful audience. And I hope you have a great day. And thank you so much. There are some more members are present. Gambhir sir, thank you so much. Anthony sir, many.
Also, Dr. Pradeep Jawandia.
Yes.
He's not from Mumbai, but he's there.
Yes, thank you, Jawar sir. So